Good afternoon, or morning, or whenever you're watching this, and welcome to the second edition of Algebra 2 Notes with Miss Faust. Today we'll be talking about the notes for lesson 1.2. Our essential question is, what are some attributes of a function, and how are they related to a function's graph? So basically we're looking at some vocabulary that you'll need as we move through the year. You should already have watched the video and taken notes on linear functions, and you should also have notes from class on domain and range. So this should be your third set of notes. It's our second video, but third set of notes. So in order to get started, if you need to pause and get your stuff together, you can. You do need this piece of paper, which I gave out in class. I've just folded mine in half. This is gives you some of the examples all set up already. You can cut and paste this into your notes when we're done, but we're going to do a lot of coloring on it as we go through today's notes. So you'll definitely need that handy. You need your notebook all set up, and you need some different colors. So I will see you back here when you're ready. Okay, there you are. So our first thing we're going to do is just get some definitions down. So the first definition is for the average rate of change. And the average rate of change, if you think about rate of change, hopefully slope comes into your mind somewhere. So that's really what the average rate of change is. When we're looking at complicated graphs, we're looking at the slope between 2 points on a graph. So you'll need a graph, or you'll need coordinates to do this, and you always need 2 points or 2 spots on the graph when you're looking at the average rate of change. So if your points, for example, are, or we'll just call them x1 and y1 and x2 and y2, then your average rate of change, you can find using the slope formula. So y2 minus y1 divided by x2 minus x1. Linear equation, that's pretty self-explanatory, but as we get into curves and other things, that's where it becomes really important and really interesting. So that's our average rate of change. Next we have positive values. And all of this will make more sense, I promise, when we start looking at an example. We just have to get some of the basic vocabulary sort of down first so we know what we're looking at when we're looking at an example. So positive values in a function are the x intervals where the graph or the values in a table are above the x-axis, and along with that go negative values, which are the x intervals where, I left out a word there, x intervals where values are above the x-axis, so negative values, sorry about that, negative values, x intervals where values are below the x-axis. And you can't see all that, so let me just adjust slightly here. Actually, let me do that this way. There we go. 2 more vocabulary words for right now. Maximum. So maximum is the point or points, sometimes we have more than one, where the largest y value occurs. And a minimum, as you might have guessed, is the point or points where the smallest y value occurs. So to take a look at all of those now, get out your example 1 handout. Looks like this. So what you can see on here is there's a bunch of different things we're going to go through. First of all, the average rates of change, and then we'll look at positive values, negative values, maximums, and minimums. We'll leave those last 3 for right now, just to get this first part in your head before we go on. So average rate of change, remember what we need then is we need the 2 points. So if we want it between x equals 0 and x equals 4, we're going to go to x equals 0 on the graph and see what our point is there. So that point is 0, negative 2. And then at x equals 4, which is here, our point is right there at 4 and positive 2. So when we go to find the slope, we do y2, which is 2, minus y1, which is negative 2, over x2, which is 4, minus 0. 2 minus negative 2 is 4. 4 minus 0 is also 4. So our average rate of change there is 1. Same thing for 12 to 22. So at 12 and at 22, I want to find my y values. At 12, my y value is 2. At 22, my y value is 0. I'm just getting those from looking at the graph again. So my slope formula, y2 minus y1 over x2 minus x1. So I get negative 2 over 10, which reduces down to negative 1/5. So that's the average rate of change between x equals 12 and x equals 22. I'm going through this kind of fast. Feel free to slow down, pause anytime you need to. Average rate of change from 8 to 16. Well, at 8, I'm here. At 16, I'm here. So 8 is negative 2 for the y. 16 is also negative 2. Slope formula, negative 2 minus negative 2 over 16 minus 8. Negative 2 minus negative 2, well, that's just 0 over 8, or 0. Makes sense if you look at where those 2 points are and you imagine connecting them with a straight line. You can see that the rate of change between those, or the slope that would connect those points, is 0. And that's really what the rate of change, the average rate of change is when we're just looking at one part of the graph. Okay, so on to positive values and negative values. Positive values are always going to be the x intervals, so we want to look for the x values when we're above the y-axis, or above the x-axis, excuse me. So I come up here, and what I notice is I'm above the x-axis in that interval, I'm above the x-axis in that interval, and I'm above the x-axis in that interval. So the way I'm going to write that is I'm going to actually write intervals with x's in them. So when 2 is less than x and x is less than 6, I have positive values. So that goes with this first little pink line. When x is between 10 and 14, I also have positive values because I'm above the x-axis there. So I don't care about what the y value is, just that it's above the x-axis. And finally, from 18 to 22, I also have positive x values because we're above the x-axis. Negative values then, I'm going to switch colors. So we look for everything below the x-axis. So here I'm below the x-axis, here below the x-axis, and here. So again, then I just write those in interval notation. So between 0 and 2, between 6 and 10, and between 14 and 16, I have negative values. As far as maximum and minimum, so maximum, I look for all of the points that are maximum values, and I want to look for what those coordinates are. So highest y values are those. I'm going to look for what the coordinates are there. So that one's at 4, 2, that one's at 12, 2, and that one's at 20 and 2. So my maximum values, I'll just record those down here now. All the places where the y is the biggest it can be. Minimum values, probably starting to get the hang of this one, and that one. So 0, negative 2, 8, negative 2, 16, negative 2. Are our minimum values. So if you're unclear on any of that, this would be a good time to stop and go back and maybe rewatch something, listen to it a second time as you're following through. Sometimes just hearing it one more time is helpful. And notice this point at the end, this 20, where x is 22, that's not a maximum or a minimum because the graph isn't really going up or down from there. So that one we wouldn't count that in this case. We will count it when we get to zeros, but that's coming next. Okay, so finish that. Pause if you need to, and we're going to go back to a little bit more vocabulary. So we only have 3 more vocabulary words. I'm going to a new page just because I don't like scrunching it up at the bottom, and it's probably easier for you to see if I do it this way. So our other few words are increasing. And increasing, again, we're going to talk about intervals here, just like we talked about intervals with positive and negative values. So increasing intervals are the x intervals where the y values are getting larger. And we always go from left to right for these. Decreasing intervals are x intervals where the y values are getting smaller. So as you go from left to right, if your graph is going up, you're increasing, and as you go from left to right, if your graph is going down, that's a decreasing interval. And we always talk, when we talk about these, we always use the x values because those are our independent variables, so it's always the x's that go into our answers. And finally, zeros, and this one's probably familiar. Zeros are all the places, we'll say points to be more precise, where the graph crosses the x-axis, also known as x-intercepts. Okay, so back to this beautiful graph we were looking at before from example 1. So we can get a little bit more of it to show up. There we go. So now we're going to fill in increasing intervals, decreasing intervals, and zeros. So our increasing intervals, again, are where the graph is, values are getting bigger. Let's see if I have another color for that. I do, yay! Okay, so this graph is getting bigger on that interval. It's getting bigger on that interval. And it's getting bigger on that interval. So I look at the x values, and I've already got them labeled. That's kind of nice, between the minimums and maximums. So my increasing interval is between when x is 0 and x is 4. That doesn't show up. Let me just switch to a regular pen. Increasing interval between 0 and 4. Here's 0, here's 4. Increasing interval from 8 to 12. So I write 8 is less than x is less than 12. And increasing from 16 to 20. Decreasing intervals, places where it's going down. Basically all the other ones. There can be intervals that are neither increasing nor decreasing, but we're not going to look at those today. So decreasing from 4 to 8, decreasing from 12 to 16, and 20 to 22. 12 to 16 and 20 to 22. And notice I'm just using less thans in all of these. Right at 16, for example, the graph is neither increasing nor decreasing. It can't be increasing or decreasing at a single point. It can only be increasing or decreasing as we move along the function. So as we move this way, it's increasing. So when x is greater than 16, that's what this means. It's increasing. On the other side of 16, so when x was less than 16, it was decreasing. So that's how that works. And finally, zeros. Zeros are our x-intercepts. So I've got one right here, one right here, one right here, one right here, one right here. That's a lot. 0, oops, not 0. The y's are always the zeros. 2, 0, 6, 0, 10, 0, 14, 0, 18, 0, and 22, 0.